Welcome to this special Armada International podcast produced in association with L3Harris. I'm your host Tom Withington, and we're joined today by Tim Elliott, Head of Sales and Business Development for L3Harris's sites in Tewkesbury and Fleet in the United Kingdom, and Rob Hall, Product Management Lead. We are talking about the Counter Small Uncrewed Aircraft Systems, or C-sUAS battle. Ongoing and recent conflicts in Ukraine and the Middle East underscore the danger that these aircraft pose on the battlefield. Whether being used for intelligence, surveillance and reconnaissance gathering, or munition-armed, first-person view uncrewed aerial systems are employed as kamikaze weapons and threaten the manoeuvre force. As in previous wars, it is vital that manoeuvre units do exactly that. They must keep moving and complete their missions, kept safe from the danger of drones. L3Harris's CORVUS portfolio of next-generation electronic warfare systems are ideal for the C-sUAS fight on the non-static battlefield. Tim and Rob are joining us today to talk about C-sUAS systems and their place in the manoeuvre force. Gentlemen, thank you very much for joining us. To start with, do you both feel that uncrewed aerial systems will be a hallmark of future conflicts, and if so, why?
Hi Tom, thanks very much for hosting us on your podcast. It's a real pleasure to be here today. In answer, UAS are here to stay. It's quite interesting coming as an ex-military operator and a student of the Western way of war. We in the West have kind of ignored small UAS for quite a while. We were there investing in big I-Star expensive platforms, and then right underneath our noses a lot of developments were happening in potential adversary nations, and nobody really paid attention to it. You know, there was a utilization of drones in the first Russian operations taking place in Ukraine from 2014, but really until Nagorno-Karabakh, that's when we really started noticing a massive uptake and utilization of small first-person view drones and UAS. So I don't see that's going to change. And the reason for that is that they are cheap and they are effective. And as soon as an enemy force is maneuvering, if they're seen by the drones, they are potentially dead. So our adversaries have found a way to utilize potentially very cheap capabilities and give themselves an I-Star capability that traditionally was only available through very expensive providers to Western nations. And that's turned on its head. So I think that's one of the main drivers for why they're not going to be going away. Secondly, that ability to use the FPV elements of it enables highly accurate targeting. Now, before, we've seen Tomahawk missiles and the like since, first Gulf War and the TV pictures then, but that was only available to certain people, and clearly Russia's invested in targeted munitions, as has China. But now you've got highly targetable munitions available for a very, very attractive price point. So that maneuver warfare is going to be essential. To be still is to be seen, and to be seen is to be dead. But even moving is now a challenge. So I don't see personally any kind of UAS moving away from the battlefield. They're ubiquitous and they're here to stay.
And I'd absolutely agree with that. And the other thing about the UAS is it's something that the users can adapt for themselves. So they don't have to wait for vendors to make changes. They can buy components, they can plug them in, they can change the functionality of the UASs and try and hop around the defenses that they are coming up against. So because of that ability to move capability at speed, I absolutely think that it just will be here for the foreseeable future.
What are the key challenges in providing counter-small UAS support on today's battlefield?
Well, for a start, there's blooming loads of them. You can buy a very cheap, very small UAS off Amazon, and Jeff Bezos will deliver it to you within 24 hours for less than 20 quid. Now, that might not be particularly capable, but when you start spending a few hundred or a few £1,000s, you can get something that is really very capable in a modern battlefield. So there's loads of them in the Class 1 area. And when I say Class 1, I'm talking in the small UAS, so lightweight, generally at that visual line of sight kind of distance, low band RF, rather than sort of something with more persistence where that becomes more of a kind of GBAD challenge. So it's that small, cheap end that is the real challenge for for all militaries at the moment. But I think, one of the main reasons they are a challenge is because of lots of them. Secondly, they are becoming ever more resilient. A few years ago, you'd almost see videos from counter UAS providers where, the cartoon would show someone pressing a big red button and then 6 drones would fall out the sky and crash onto the ground. That simply doesn't actually happen. They are resilient for a few reasons. Firstly, what's happening in Ukraine is people pushing the boundaries of the technical parameters of what's available to them. So they might buy a drone. It says that it's going to transmit on certain frequencies, but they're really playing with that technically to enable much more freedom in the spectrum and give themselves resilience. And then secondly, outside of conflict, I mentioned Jeff Bezos earlier, but at some point companies like Amazon are targeting the ability to deliver by drone. We know that at the moment, but if you have a drone that's going to fly past a high-rise building with 400 Wi-Fi routers all transmitting an independent signal in there, you need to be highly resilient in your control frequency. So it's not deliberate to make it difficult for militaries and security professionals, but the effect is the same, that actually the more resilient the control frequency is and the more resilient the drone itself is, and that's really resilient in terms of how it can fly in a congested EM environment. That has an effect on the military battlefield as well. They're more resilient there.
And I'd say from the equipment provider viewpoint, the ability of the user to tweak the signal frequencies means that they will be looking for gaps where they perceive that there is no jamming capability. So as a system is deployed, the counter to that will very quickly become outdated. So the detect and response system has to adapt very quickly. And it's not just in the traditional frequencies where we might have thought of drones operating, such as the 2.4 and 5 gig Wi-Fi bands. It's pretty much going to be anywhere around the EM spectrum. I think the other thing that is a challenge is that the use of small drones on the battlefield is pretty new to a lot of the user groups. And therefore, the techniques and tactics that they're going to adopt in order to counter those has to be pretty quickly developed. And the other thing is, because they're ubiquitous, the response has to be ubiquitous as well. And therefore, the cognitive and the size weight power overload that the people are experiencing already has to be minimized. So how can the system both warn them that there's a challenge in the area, but not require any of their cognitive load in order to respond to it or to understand how to act? So I'd see those as the threats there.
How can we engage both solitary UAS threats and drone swarms on the battlefield?
I like to think about the counter drone in the same way that people have been thinking about counter IED traditionally. This is a force protection challenge, and in Western and NATO nations that deployed to Iraq and Afghanistan, the IED threat became significant, but you couldn't stop your mission. People still had to go out and patrol, whether there are IEDs there or not. And how did you deal with that? Well, you developed tactics, techniques, procedures, and technology went hand in hand with it to enable patrols to continue and not to get stuck inside the base. Well, it's no different with the force protection challenge from UAS. We need those tactics and we need the technology. Now, I'd say the tactics are evergreen. They are developing at the moment because this isn't something that Western nations have found themselves in that battle. So we're going to have a huge number of lessons from Ukraine. But what it comes down to is force protection and the mission freedom that you get from that. So mission freedom before was the ability to go on patrol without being stopped because of IEDs. Now it's the ability to have your mission freedom against a ubiquitous and significant in numerical number drone threat. How do we do that? Well, it doesn't mean that you need to know where every single drone is, but you do need to know about the drones that are going to potentially be a threat to you. So first and foremost, our thoughts is around actually knowing the location of a drone. Once you know the location of a drone, you as a patrol commander can make a decision. It might be flying past you. It might be 4 kilometers away. It's unlikely. I know people will talk about great optics, but generally, that's probably not close enough to call in a fire mission. It's certainly not close enough to be a kamikaze drone. So you could potentially ignore it. You might want to shoot it down, but that might give away your position. So first and foremost, how we engage, whether it's a single UAS or whether it's a swarm, we start with the location.
I'd add on to that to say that in order to engage, you need a layered threat response. So you need both the ability to use an EW response to it as well as the kinetic, because as we know, the drones will not always be flying with an EW signal, and therefore we may or may not be able to detect that. So we need a layered detect solution and then a layered response solution to run over the top of that.
Yeah, one of the things that I would add as well is that kinetic only solutions, they're not always the answer. You know, if you can imagine a patrol in a position, they see a drone, it can be expensive. Now, I know that there are additional weapon sights, for instance, that can be bolted onto a rifle to cut the number of rounds by improving the accuracy to engage a target. But that's still a weight burden, not as much as it might have been in the past, but there's still a weight burden and a cost burden using a kinetic solution. And as you go up the stack, you know, we talked earlier about the challenges of UAS when it moves to the heavier weight and it becomes a GBAD challenge. Well, missiles are extremely expensive. They can be very effective for dealing with drones. So this idea that actually kinetic solutions are the only solution, yes, they can be successful, but they are not always the answer. So the RF effects that Rob has been talking about, and a response using a non-kinetic solution, it's repeatable, it's cheap, it's generated on the soldier or on the vehicle, can be highly effective.
How can Corvus help in supporting the C-sUAS mission in such dynamic environments?
There's effectively 4 components to a drone system. Now, everyone doesn't necessarily think that. They think of there's a drone. And then they might think that there's a controller or a pilot at the end of it. Yep, those are 2 of the components. But there's actually 4 different things that you can attack: the pilot, and his controller or her controller, the drone, the uplink and downlink. And in a way, you need to interrupt any one of those 4 to give you your mission freedom if you choose to engage kinetically or non-kinetically. If you drop artillery on the head of the pilot and their controller, that might achieve the mission that you want and your mission freedom. But that might not be the right thing to do. So you need to attack the vector to stop that drone being effective on the battlefield. Now, for us, we see that the command and control uplink and then the video downlink are 2 of the critical enablers, and they are generally, not completely, but generally we're seeing a lot of the lower cost drones. That's in the EM spectrum and in the RF spectrum that we have a huge amounts of experience and huge amounts of strength and history in attacking vectors along that. And specifically, it doesn't in a way really matter what bit you attack. You know, if you take out the ability of the pilot to control the drone, then they will not be able to put the drone where they want. They might not be able to put the camera on you. They might not be able to target you. You've got your mission freedom. Or most of the time, the targeting at the moment requires that FPV. It requires a video downlink. If you can interrupt that, they are unable to do their mission and you are able to do your mission. So I'll hand over to Rob, who can talk a little bit more about how our capability can achieve those missions.
Thanks, Tim. In order to detect a drone, what you want to be able to do is to see it on the electromagnetic spectrum as far out as you possibly can. So therefore, what you're looking at having is a very sensitive receiver and have the gain on that amplified by having a directional antenna and having very high gain on the antenna. And that's where the Corvus system combines those capabilities. So that allows you to see the drone as far out as you possibly can, and then allows you to look for it so that you can decide what response you want to make, or if you want to make a response at all. And then by using the high gain in reverse, you can place a lot of power onto that signal in order to be able to jam it to either prevent the control signal or to prevent the video downlink. You also want to be able to have different scales of equipment. So if you want to be soldier carried and then deployed, you want to have a very small system. If you want to be able to mount on a vehicle and use it while you're traveling along, you want to have a bigger system. But you really want to have a common capability that runs across all of those so that you can engage very easily with the system. And equally, what we provide is a very, very simple interface. It says, there's a drone, and instantly the user can decide whether they want to do something about it. Because this has to be rolled out to a very large number of people, it has to be really simple. It has to not be something that requires a lot of training. And that's why we've really focused on making this solution as simple as we possibly can. And then because we can change the mission within the system, we can add on new capabilities which allow us to both counter changes within the drone threat, but also within other threats that are seen within the battle space.
For certain users on the battlefield, they're not going to want to necessarily transmit. So Corvus offers the ability to passively detect the drone and make that command decision about, do you even want to engage that drone, and not necessarily give away your position with a kinetic or a non-kinetic engagement. So we have that ability to process the signal and display that visually to a user through TAC or any other BMA. And that's a massive step forward for people to have that passive detection and situational awareness in their hands, in the hands of the patrol commander or every person on the patrol. You can also then network that and provide that information up the command chain and then make good quality kinetic and non-kinetic kill decisions based on accurate targeting information. We didn't have that before. No one's had that. And it's a real great development that Corvus has offered and opened up.
As a follow-up, how can assets like Corvus be integrated with the wider manoeuvre force to work both on the move and when stationary?
I mean, Corvus is such an exciting product family, and it's not just hardware, it's hardware, software, it's modular, replaceable components at both a hardware and a software level. It's what I like to call software-defined defense, where the hardware isn't the piece that's limiting you and fixing you with a capability that's not going to change for years and decades. We have developed the ability to have hardware that changes and software that changes. And it's as simple as developing a new application through Open CPI that's going to drive the hardware. And so our multi-role equipment, it doesn't just do the force protection against drones. It can carry out force protection for IEDs as well. It's exactly the same capability that's inherent into the Corvus family. And that family covers different scales and sizing with different output powers and different size, weight and power profiles, from very small form factor all the way up to vehicle-borne solutions. So it's true multi-role, covering that ability to sense signals, carry out comment and surveillance missions, and then carry out attack and deliver cyber protocols. So as a force protection asset, enabling multiple different missions and then minimizing the amount of equipment that a soldier has to carry or put in the vehicle, and as well as actually minimizing the number of programs that an IPT has to run, because it's just one single mission module that can carry out multiple missions. And there's some really exciting missions that I've mentioned already, and we're not limited. We've got users already adopting Corvus, and they're developing their own missions and protocols through that. And we don't necessarily know what it is. We've given them the training, and they're then taking that equipment, be it mounted, dismounted, patrol equipment, and they're developing their own capabilities independently through Open CPI, and then deploying it on through the Corvus hardware. It's really exciting.
To cover the question specifically about on the move and stationary, all of our capabilities are designed to be able to be used, whether it's soldier worn and therefore you're walking on the move, whether it's vehicle, or whether you have to quickly transport the kit. So all of our kit does allow you to use it both in the static and the mobile deployments.
Tim, Rob, thank you both very much for your time and insight. For those of you keen to learn more about Corvus and its C-SUAS attributes, visit L3Harris's website at l3harris.com. That's all we have time for. Thank you for listening.